Okay, welcome back to the world of science, my dear kids. Again, this is Mithun Raj, your science teacher, signing from this part of the world. So, today we are going to discuss one more time the ending part of this chapter, one of the most difficult part in that chapter. So, why it is difficult? Because this is the first time you are studying the basic concepts of physics. So, I will tell why it is difficult because you are now starting to learn about these equations. In your former classes, you only mostly studied about different names, different chemicals, their reactions, their properties, what all things is happening in our environment, about water, fire, food, and all. But now the real part of physics is starting. Okay, and the first and second chapter of physics 9th standard is a bit a bit above level than your class. But we will try repeating these equations. Okay, there's a lots of numerals in examination. 100% numerals will come. Minimum 7 to 10 marks numerals will be there, and at least 3 mark question numerals will come from this chapter. So equations of motion is one of the most important equations ever derived in this world. Okay, so now we will study how we can derive this. Okay, anyway, equations of motion is only these three. These three are the basic equations of motion. The first one is regarding velocity, second one is regarding displacement. Okay, so not velocity, first one is regarding acceleration, and the second one is regarding displacement. So how we can derive these equations? Anyway, these are the final equations we are getting simply by seeing this v equal to u plus at. What is that? Any idea about that? No, isn't it? So we need to know how we got this. So in last class we discussed about a lots of graphs, isn't it? A lots of graphs we discussed. So regarding that graph, what we want to fix in our mind is that how many types of graph we discussed? Distance time graph, displacement time graph, speed with time graph, acceleration time graph. But among that graph, one particular type of graph is there which is called as the velocity time graph. Okay, which is the velocity time graph. And we will derive the equations from that graph also. That is also important. That is a 5-mark question. Okay, 5-mark question. It's not difficult. It's just 10 or 8 or 10 steps. The answer is got. 10 steps means is nothing regarding physics. Okay, in higher classes you will deal with derivations of 10-15 pages. It's a simple derivation. Mostly like in one page we can derive all these three equations. How we will get all those things? So before going to deriving the equation, we must be apt with the terms. So what all are these terms? So we have here v is equal to u plus at. So we already studied what is v or what is u. Both of them are tell velocities. Right or not? Both are velocities. Actually we need to write a vector here. Okay. But mostly in equations we express like this, because velocity is a vector quantity, so we want to write a vector there. So what all things are there? So this is the basic things for you. Okay, this is the main thing of that chapter. In the first page of that chapter called motion, write the heading chapter 8 or 9. In old textbook 9 I think, now 8 I think, I am not sure about that. New textbook didn't came, I didn't got it. So write chapter motion and you write these three equations. Equation. Actually this is called the kinetimical equation. Okay, kinetimical equations, and you want to write all these terms, explain all these terms while you are deriving an equation. Okay, deriving means from simple things what we know, we will make it a firm equation. Okay, so and what is the use of this equation? Any idea? any use of the, anyway there must be any use, otherwise there is no need of studying equation. There must be some use. So what is that use? That use is regarding in our daily life we can find out this acceleration of a car or a plane, the time taken by the vehicle to reach from one place to another, isn't it? For example, if you are traveling from Mumbai to Delhi, we need to know the time, how much time it will take. For example, tomorrow you want to attend a conference at Delhi. So you must be 100% sure that how much time before we need to leave from Mumbai. Okay, if you don't know that time, maybe you will reach there and the conference is already finished. So it is very important to know the time for the travel to take, isn't it? You must know the time. So these types of equations we are using it. Understand? So let's see. The second equation is about S. What is S? Anyway, in different textbooks we will write different terms. These are constants. We can use any letters, but one thing, in an international reference scale we are using V for, where is he? This one, final velocity of that object, okay, of that body. U means initial velocity, the starting velocity. V means the ending or the final velocity. And what is A? You know, acceleration. There is no change in that. A means acceleration. T is time. 100% T is time. S, capital letter S, is displacement here. Okay? Displacement. Distance we are not taking here. We are taking displacement equations for that. Okay? Now it's time how to derive all these equations. If you can, you just take one paper and a pen with you while seeing this video. Okay, it will be more helpful for you to how you will get. So just 1 minute, just take one paper and pen. We will see. Okay, the first one is called as V is equal to U plus AT. That is the first equation. We will write it here. So V means what? Initial velocity is equal to final velocity is equal to initial velocity plus acceleration into time. So how to derive this? Let's see. So what do we have regarding this? This one, acceleration. You studied some equations, I think, isn't it? What is that equation? What is the acceleration? Velocity divided by time. Am I right? Velocity divided by time. That is acceleration A is equal to velocity by time. Simple. But here how many velocities are we are taking? In the case of motion, we are taking two types of velocity. Isn't it? If motion occurs, there will be two types of velocity. Initial velocity and final velocity. So let's see. So we have initial velocity, we have final velocity. So we need to take average velocity. What is this? Final velocity minus initial velocity. That is, we have A is equal to V minus U by T. Simple equation or not? We studied that in the acceleration part. And now comes the application of mathematics regarding this equation. Okay, basic application of mathematics. I think you already studied this, otherwise just one more time. During this derivation of equation, keep in mind that whenever something is be getting divided, understand? V minus U is divided by T. If we take this T and if you want to put it in the left side of the equal to. Okay, equations means what? Two sides are there. Okay, the left side and right side, isn't it? In the center there will be an equal to, and equations means we can change each alphabets or each signs inside that equation to the left or to the right, so that we will get what all things we need. For example, if we want to get acceleration, we already have the equation. From this equation we need to get time. Take the time here, bring the acceleration here. Same equation. Understand? But here what we want the equation for velocity and final velocity. So for that purpose, first I will bring this t here. Will become at is equal to v minus u. But still we didn't got this equation. Correct or not? This also has some difference here. Alright? Some difference is there. See, at is equal to v minus u, but here is equal to v is equal to u plus at. So how to make this v alone here? We need to make that v alone, then only we will get the equation for final velocity. So another rule is there regarding mathematics. If we move from right to left or from left to right, just change the sign. There won't be any change in value. So here u is negative. We can take it here. See, then it becomes, here u is negative. If we take it in the left side means it will become positive. U plus at is equal to v. Is this our equation or not? Understood? It's a simple equation. The first one is very simple equation. We derived it from the equation already we have of acceleration, which is the rate of change of velocity. Rate of change of velocity means final velocity minus initial velocity by the time taken. Okay, it's a simple derivation. From the same equation you can get the equation for final initial velocity. How? Just take this 80 there. Isn't it? So u is equal to v minus 80. Right or not? So why I am telling this, whenever numericals come, numericals will come. For example, final velocity is 10 meter per second, anyway second velocity is 6 meter per second, total time is like 5, find the acceleration, like that questions will come. So in that what we want to do, we want to find out, from this equation we can find out the acceleration, we can find out the time, we can find out the initial velocity and the final velocity. Okay, whenever these four terms are there in the question, we want to use which equation? This one, v is equal to u plus at. Okay, see, I think it's not very difficult. You must know the concept, otherwise it will be very difficult for you. Just imagine, we already studied the first equation. What is acceleration? Acceleration is the rate of change of velocity with the time. So we have the equation, acceleration is velocity by time. But here two types of velocity is there. That's why we are taking v minus initial velocity minus, final velocity minus initial velocity, v minus u. See, it's very simple. Just see. My pen will go out. Okay, see. Final velocity, initial velocity. Okay, time we already know. We can take the t here. It's a mathematical rule. Okay, it's the mathematical rule. There is no solution or derivation for that. It's a common rule regarding equation making or deriving equations. So we can easily take t to here. T went there. So what happened? At is equal to v minus u. Again we want to take u from here to here. U minus, change the sign, positive, u plus at gives v. V is equal to u plus at. The equation we need, the same equation will give one more equation, u is equal to v minus at. But this is the universal equation we are using. That's why this is the first equation regarding this final velocity. Okay, so the first equation of motion is solved, and this equation we can use whenever questions come to find out either initial velocity, final velocity, or acceleration or time. Okay, in the question 2 or 3 terms will be given. Okay, for example, initial velocity will be given, final velocity will be given, time will be given. You need to find what? You need to find the acceleration. In the opposite case, sometimes time will be given, acceleration will be given, initial velocity will be given. You need to find out the final velocity. Okay, so that's the first equation. I hope you understood this. This is a very simple thing. And now we have a new equation also. Find Right or not? We already have a lots of equation for distance of no need of equation. Displacement also no need of equation. Speed we already know. Distance traveled by time taken. Velocity we already know. What? Hmm. Displacement by time. So acceleration what? Velocity by time. Rate of change of velocity, isn't it? So we have another equation, v is equal to u plus at. Understand? By using this equation and the equation of displacement. What is the equation for displacement? Or velocity, sorry, not displacement, velocity. Velocity equation is, velocity is what? Displacement divided by time. So the second one is regarding displacement. This equation we will add displacement into the same equation above and we will get this equation that we will discuss in the next class. If we discuss all these things in one class, it will be very confusing for you. So I hope first part was easy. Second part and the third part, a bit more steps are there, but it's also simple. You need to substitute each and every terms. Okay. For example, here v is equal to u plus at. Wherever we see u, we can substitute this same formula. For example, here if we substitute u plus at, what you will get? U plus at is equal to u plus at. Okay, that's not an equation, that's a simple equation. Just joking. So this is, I think time is finished. So next class we will again meet one more time. So till then, Raj signing from this part of the world. Stay at home, stay safe, be safe, make it, eat good food, drink great water, and be safe. Bye bye and Jai Hind.